so we get everybody start talking about something. I'm opening up my discs. Let's see. I have questions. Yeah. So, thanks everybody for coming out. For the second panel discussion we've ever had. The first one wasn't really a panel so much as it was one person and the audience. So, in any case, today I thought it would be really cool to start talking about like VR and AR stuff, because a lot of people in town, I know, like us at Carbon Time have implemented that, people at the library implemented that. I don't know if anybody here has played with it, but I was talking about VR and AR and kind of ways we can get started with that. So I asked some people who've been doing a lot of that stuff to come up here and sit, and we can kind of go through some questions and also take questions from y'all. Cool. So that's a little bit of the agenda. So just to kick things off, I think it'd be really good to go do introductions and just say who you are, what your experience is. You can say where you work if you want to, and just kind of what your background is. So.
Hey, I'm Rick Tomlinson. I've been in Chandler for about 3 years doing augmented reality for most of that. I worked at MapArt Systems, Second Sight, and Carbon Objects, now Bell Labs. But all three of those did augmented reality for different applications.
Just Bell Labs doing augmented reality?
No. Not yet. We'll move your like second life house. Virtual. Actually, being able to see like your stuff in the room would be really
Don't rationalize this.
I'm just saying.
All right. All right, I'm Alex Cruikshank. I'm General Manager at Carbon Pipe Chattanooga. I have been doing a lot of visualization stuff for a long time, and I've been playing with VR, a little bit of AR, and just generally doing a lot of stuff in the browser. That's mainly where I'm focused, although I've been doing some YouTube stuff too.
I'm Sean Brewer, I'm a Chattanooga Public Library. I'm the net specialist and also over the Peak Lab. I have worked a lot with especially web VR, and part of the purpose of Peak Lab is to bring, or one of the purposes is to bring new technologies like VR to the public so that you can experiment with it. So I have a lot of experience working with web VR, and
I'm Kyle Gordy. I work with Sean at the library. I'm their designer and developer. I've been playing mostly more on the consumer side of using VR. We have a couple Oculus Rifts up there to play with, so if you haven't came out and played with it yet, you definitely should. And I've been playing with cool cardboard a lot too, because I got really interested with Oculus Rift and because, trying to save some money. So I was like, oh, I'll try cardboard, and it's really cool. But as of this morning, I actually started playing with VR and wrote just a quick little prototype.
Awesome. And for those of you guys who don't know me, I'm Chris, and I've been doing a little bit of AR and VR stuff on the side of the ops. So the way this will work is I'll ask a couple questions, but y'all feel free to chime in on this as well. If you have stuff, I guess raise your hand. Just be civil. But yeah, we'll kind of just go from there. So to start it off, why is virtual reality and augmented reality a thing now? Like why is this suddenly taken off as a whole?
I can kind of take that one. I don't know if any of you read it, but there's a really great article that came out there. It's Mark Andreessen, it's a big venture capitalist in Silicon Valley. And he started talking about, it wasn't just talking about VR, he was talking about basically VR and drones and Internet of Things, and basically all these like nice little like hardware devices that we have now. We're talking about how it's all really come out of the mobile phone industry and how mobile phones, so much money has gone into mobile phones, so much research has gone into mobile phones, and at this point, the supply chain for mobile phones has become so sophisticated that we have all these cheap components that are put into the cell phones. We have we have like really high resolution screens, and we have accelerometers that are cheap and small and don't use much power, and all these other components that, like a lot of the technologies that we see coming out right now are because we have like basically there are the different mixes and matches of all these like hardware components that are now affordable and really good because they've been developed for the cell phone industry. So I think what's happening now is like a while back, Oculus came out and decided for some reason or other they wanted to do VR, and they realized that they had the technology to do it. They could like they could create this fairly affordable device that was actually pretty good, way better than it ever could have been in like 20 years ago or something like that, when VR was like a big thing before. And so they decided to go for it, and people were into it, and I think this spawned the whole industry. So I think it's really just like, it's because the hardware is available now that, that we're kind of getting more into it. At least in the VR space. I don't know if you want to talk about the VR space.
Yeah, I think AR is kind of the same way. We're getting to the point where your phones can actually pull this stuff off in a realistic way. And it actually can make a compelling experience instead of just having things kind of jump around. That goes for GPS and for like now, when I first started out there, you could put things, you know, in physical locations with GPS coordinates and turn them, and it would be a little bit wonky, but work pretty well. Now we've got the SLAM algorithm, simultaneous location mapping. It's what the Curiosity rover uses to basically place itself in free space by making a point cloud and attaching images to it. You can now make those maps on your phone with relatively high accuracy. And so you just move your phone around, and all of a sudden, when you've got a 3D map, you can put things on top of it. So the ease with which you can do that and the realistic experience has really come a long way since the last year.
You know where the SLAM algorithm came from?
NASA and I think we're done as well. Google
Yeah, so
does.
it actually was for the rover.
Yeah.
That's a good answer. So.
Okay, those were good answers.
Yeah, I would agree. The follow-up to that, I think, is, so we talked a bit about like the technological advances, I think some of us probably remember the 90s of VR, but like, wait, I never actually looked into the, yeah, there's virtual.
I have one.
You have one?
I haven't.
Do you still have it?
I don't. I know.
We're in red, like red.
Yeah, like, I've never actually looked into like the red screen of death, so I don't know what that looks like. But is the technology what's going to separate now from then, or is it something else, some social thing? Or?
Yeah, I think access to technology is way above and beyond than what it was in the 90s. So more people are able to work on this stuff. Like, you don't have to have access to a big fancy lab to deploy or even work on virtual reality projects. I mean, you can sit in your garage and buy all the components cheaply to do the work. So I think we are in a way better place than we were in the 90s. Well, much better. So I'm really excited about the things that we can do with basically this new iteration of VR and AR.
For content creation, you're back to the phone bit, like Google Photosphere, like it's just a thing now. Like pretty much everyone's phone in everyone's pocket can do it. So if you need to generate a 3D panorama, you can do it pretty quickly. It's not gonna be amazing, but
qualify that, like amazing by what standards? Like where do we live? Where, like, what time are we in where we can like open up this image and look all the way around and that's not amazing? Like, you know what I mean? Like, just throw it out there.
I think, like comparing now to the 90s, I think one of the things is that in the 90s, I think it was really people wanted to have VR. It was kind of an extrapolation, like 3D, like spaces, like computer simulated 3D was kind of just a big thing. And people were like, oh, wow, now that we're doing this, wouldn't it be great if we could kind of like look around in it? I think there's been research done on it for a long time. And I think we got into the 90s and a lot of people wanted VR to be there. They're pushing for it really hard. And I don't think the technology was there. I think like basically it was just, you just couldn't make it cheap enough or work well enough. I mean, you can imagine having these CRT screens on in front of your face, or like, there's like the LCD technology was just not there yet. And so, now we're in a situation where it's actually kind of reversed. It's like, now we have all this hardware without even really wanting it. It's kind of like, it just kind of popped up on the screen and we don't really know what to do with it. It's like, we just like, oh, well, maybe we should do VR now that we can do VR. I kind of feel like that a lot of that's what's going on right now.
Yeah, I think a lot of it's probably bandwidth driven, and that enables the applications for it. Like people can say, oh, we can use 3D VR for this, because I remember in the late 90s, there was a company in Hungary called iCase, and they did photospheres, and their clients were all real estate agents. And it was great, except if you were on AOL dial-up, and you waited like 20 minutes to download one like panorama that you could look around with Java, and it was like 16 by 32 or something. It's freaking tiny. And so like now with bandwidth, it's like, oh, now we can just do like 3D Skype and use that to actually collaborate on a project or have cyber sex or whatever we do with it. But you've got the bandwidth for it, like it actually enables a decent experience.
We're gonna do this. So I think right now we're finally starting to see some like real world uses for this technology where we didn't have a lot of compelling use cases before. There's a company in Waconia right now that's using Oculus Rift for architects to help people kind of move through the 3D models that they already have to experience the place before you're actually there. I did that for the Smithsonian that did the same thing on the outside. We used AR to put a museum on top of the construction site so you can see what it would look like, and the lighting would change throughout the day, so you can see what the museum would look like there. As we get more compelling use cases and better content, that drives adoption, which drives technology, which drives content, and that's why a lot of the industry reports say that we're going to go from hundreds of millions to tens of billions in the next 5 or 10 years.
With that, I mean, it just made me think when we're talking about the difference between the process of processing power in the phone versus your flip phone that you did have in the late 90s or whatever. So are you seeing like when we talk about real-time mapping in front of you, are you seeing places like State Farm or Progressive or anybody who's thinking that let me map the accident I just had so I don't have to do, are you seeing that type of stuff?
So that's actually an idea that we had at one of my companies about 3 years ago.
I'm just trying to see.
Yeah, kind of, you could tag on the car, where there's a scratch before you check it out from the and at that point, it wasn't a compelling enough experience for it to work, but in the last 3 years, we've come far enough that it could be. And there is definitely, there's increasing interest in those kinds of
You could easily now, like next time you're like get up the phone. Hopefully this doesn't happen, but do a photosphere, and that way you have like a 3D view in time of what was going on to protect yourself.
I had a drink recently, so that would be great.
There you go.
I apologize, I'm just too much here, but are you seeing a move toward VR and or AR in the area of the big data visualization for the enterprise data visualization?
I think well, first of all, like to use AR or something like that, you need to have some reason to be in some space that in order to map it onto. For VR, VR, I think you can do it. I think one of the big issues with VR, and kind of 3D like visualization in general, is just that when you do it in 2D, you're packing everything into the right space, into a square, and you can design that space. When it's in 3D, you kind of like, so when you do like a 3D walkthrough or something like that, you're using a lot of instinct in your brain to like go through and like, like the things that like help you hunt rabbits and swing through trees or whatever, it's like those parts of your brain are like kind of activated and allow you to kind of intuitively understand the space, the 3D space. And I think that's helpful, but at the same time, it's like, it's a lot more space. It's a lot harder to design a space to like actually show the information conveniently in a way that you can like process it. And also we're not used to like thinking about data in 3D. And so I think there's a lot of opportunity there. I think it's going to be really interesting to see how people explore that. I haven't seen a whole lot of it so far that really works.
I think one of the challenges on that is that a lot of times you have to invent access for those who lay something out in one dimensions in an official way. It's not always intuitive. A, it's not always obvious how you would do it. And B, the person that would be using it would not necessarily would know that that's what you do.
Right.
But I'm thinking in terms of time series data, it would be nice just to be able to walk around and look at in terms of the sheer volume.
Right.
But I don't know how you do it.
One of the things is, I mean, we often do want to present data in 3D, or 3 dimensions of data, and so we have ways of doing that. We can show it on the screen, but when you do that, there's like, it's always like data that is obscuring other data, things like that, so you need to have controls to kind of move around in that space, and those controls are very unintuitive generally. And so it would be really nice if you could actually just like have a 3D graph and you can just look around it from all angles and things like that, just kind of understand it that way.
Sean touched on, sorry.
Yeah, traditionally, like 3D visualization is really bad anyway, even with controls. So I think there's a lot of work in the design space to figure out like what ways, how can we approach visualization in AR or VR. But if I remember correctly, Mr. Duke, I can't remember his actual real name. He actually had. I think they worked on it together. They did a visualization demo in VR, web VR. I can't remember the name off the top of my head. I mean, and we were going through it, so they sort of take you on tour through the data basically, but going through it, I just didn't understand what they were trying to show me. So I think there's a lot of work to be done. I think it'd be a great use case for VR.
I'm sorry, I didn't catch his name.
Well, I think it was there's this
The 3GS guy?
the 3GS guy. His handle is Mr. Duke, but I can't remember his actual real name. And I think Mike Bostoff is involved.
Mike Bostoff is the E3 guy.
Yeah, but I think he might be involved. I just can't remember. I just have to find it.
I mean, one thing to remember that we're talking about visualizing data in AR is like, that was the kind of, if you look back in the early 90s when this stuff first started coming out, like it was DoD and it was visualization. It was, a tank mechanic being able to see a part that's too hot, like in real time while he's underneath a tank. So I think it's interesting. I'm really interested to see as we get more and more environmental data, not meaning like ecologically environmental data, just data about our environment, and are streaming those products. Like, how do we use streaming data, which I think is more important than necessarily the kind of data sets that we look at a lot, in an AR perspective, right? Because if you're looking at historical data, you're going to have been able to do a lot of analysis on it, and you're going to be able to kind of say, this is where I need to go focus on. But if you're using streaming data, then you have this opportunity where AR makes a good platform for police officers driving down the street to like notice things, right? That you would have to have, that maybe we're really not good yet with analysis.
Situational awareness.
Yeah, there's like, so basically with IoT where you're starting to put sensors and everything, I think that's going to be a really great case for AR where like it's going to be hard to understand what that sensor is actually doing, where it is, why it's there, things like that without being able to see it in place. And so like you can imagine situations like a car engine, a tank engine, or something like that where you have these sensors placed within something and you can't see them, but they're there, and with AR it'll give you that kind of like that sixth sense to like get in there and like understand that data, where that thing is, its relationship to other things. So that's a big potential.
Just one quick random thought. You mentioned streaming data. I was listening to a podcast on the hour of big data. It was on streaming data. He showed an interesting concept. He said, I forget what it was, one of the recent episodes. He said that their group is using Hadoop, I think, find approximate answers with screen video. Because we're trained in the business world, we gotta find the exact answer, but it's interesting that we got so much data flowing through, it's good enough, maybe the AR with this twist where approximate answer would be a good fit.
Yeah, I know they're working with, sorry, I know they're working with, like computational fluid dynamics data sets. You can look at the whole data set and map, you know, pressure over the whole surface, and every frame of that is a gigabyte. And you have these like multi-terabyte data sets that you're looking through, but you're really interested in one number that comes out of it, which is aggregate lift, maybe, or the total drag on the body. And so, like, doing VR to look at the whole thing can be helpful to see where the simulation might be going wrong, and troubleshooting. But in the end, you're interested in boiling that down to like one scalar value, and so that's a hard problem to. There still needs to be a human involved in like mapping that, even with those huge data sets.
So Sean touched on something that I think is really cool, and that's accessibility of tools. This is a while ago. So I think I think a good segue here is to talk about the kinds of tools that we're using, that y'all have been using, and you know, I know the experiments I've done with VR and AR. I've been able to get something running really quickly. So it's also maybe a good time to like some stuff that you find work on, and kind of demonstrate those tools. So you know, like some talk about
Do you want to go ahead and show? So, and I'll just give a little bit of background for you guys that don't know. So this is an Oculus Rift. What it is basically an LCD screen in here. It's got two lenses. So what happens is you end up projecting on one side, like the right eye on one side and the left eye on the other side, and the lenses kind of make that full screen. So like what you're getting is like a surround view that is 3D. It's stereoscopic because it has two different images, and then also it's got a really good set of accelerometers. The thing I don't have on here is a camera. There's a positional camera because, like, while it's pretty good at like determining the rotation, it isn't good at telling like when you're going this way, back and forth. They're just not quite that sensitive enough to do that. So there's a camera to kind of deal with that. And there's a big issue with VR, which is I can't remember what it is, something sickness, where basically people get seasick because they're in VR. And what's happening there is that they're getting all this information into their brain, visual information about what the position is, which is the whole point. But it's not quite good enough and not quite fast enough, and their inner ear is giving them a different signal. And those two conflicting signals actually is what causes seasickness or motion sickness. And so it's a real problem. A lot of people get it. The solution is better positional tracking, faster or like more accurate accelerometers, and really high, not frame rates, but low latency in the tracking. So it's like basically you have to, like when you get a position, like a measurement from this thing, you need to show it on the screen, and people are saying less than 20 milliseconds. So basically you're running at 60 frames a second, you need to make sure that every frame you have the right measurement to avoid sickness, that lagginess. Some people don't get it very bad at all. Some people, like I know, if I'm in it for like 20 minutes, it gets kind of bad, but that like normally it doesn't bother me. Some people it's instantaneous. So sorry, this is a digression. So obviously you can't see the 3D experience, but you can go ahead and
But
talk
I'm sure you can come up after this.
Yes.
Totally.
Trying to set the cardboard because this demo is actually constructed with VR.
You want to talk about what we process? Do
Like
I?
cardboard?
Like cross your eyes and like.
You can do the
The whole thing, it does work.
Right. But speaking of like tools and how ridiculously nice, as simple as it is to put together,
You did this today, right?
I did this in like 20 minutes before I came here. So it's something that like this concept I've been kicking around in my head for a while. I'm just like, man, I need to do it. Time. So I was mountain biking in Stringers Ridge, and I was like, I'm gonna do a photosphere, so I can, when I get home, I can show my wife where I was at. Like, we can put it on the cardboard and be like, hey, this is where I was at. You should come mountain biking with me next time. That's just like a persuasion tool, I guess. But anyways, so I was sitting this day, and I was like, I want to do this like 3D panorama thing, and I want it to be at like Chattanooga landmark, so people can. Nice. So the concept is like you can get a virtual tour of Chattanooga without having to leave your desk.
There's a mic over there.
Yeah, that's my bike.
You can all the way down and see Cowboys foot.
You can see one foot.
It's like a
Right.
It is really creepy.
But basically, all I did is I went to Moz VR and I checked out their GitHub page, and they have some. This is pretty much their demo. It's like a panorama with just an image tooltip that describes what's going on. I cloned the repo. I switched out some image paths, replaced their panorama image with my Google Photosphere, and called it done. Put it on GitHub pages, so GitHub pages hosting it. Anyways, so I want to build this out and actually learn how to create these panoramas with SLR. So we'll have like nicer image to start with, and just kind of build it out. So if any of you are interested in wanting to help hack on this with me, it'd be fun. So that's it. With the like a Google Photo app. Yeah, I don't know if it's for iPhone.
Yeah, that's Android.
Is it an Android only thing?
Yep.
There's probably other apps that are in the iOS App Store that allow you to create 3D
No, you can be in it.
Oh, yes. You
There's
can,
there's an app called.
yeah, he's basically just created a bunch of photographs, and it's just.
Is it
Watch out.
Google for Photosphere?
You can't move around.
Google Photosphere, yeah.
You can kind of move.
It's on the iPhone?
Yeah.
Awesome.
Looking for the small thing.
It's for iOS.
So,
Beggars Canyon.
so this is something I did. It took a little bit longer, 20 minutes, but it wasn't really that much worse. So basically, all I'm doing here is I don't know if any of you have used 3JS, this 3D in the browser technology, or it's a JavaScript library that makes that pretty easy. So basically, this is 3JS. There's a project called WebVR Boilerplate. And so what you do is you start off with WebVR Boilerplate, which just like basically is a VR cube. But the great thing is it works in Oculus. It works in
It's got polyfills for all the different.
cardboard.
Right, so it will take like what you have and bring down.
Right. And one thing I should mention is this is like technology that's being built into the browser. So this is actually using Chromium, like the latest, a special version of Chrome. And there's also Firefox Monthly, which sometimes doesn't crash. So we actually couldn't get it up and running. So the thing is, all you had to do to make this work, or I had to do to make this work, was create this space in 3JS, this tunnel, which is just kind of like a cylinder with like points randomly put in it. I gave it like a texture, this shiny texture with the lines going at it, and then basically make it move. And so that's all just like standard 3D stuff. And then it just all works in WebVR because like WebVR is actually, all it's really doing is it's creating two cameras where the camera rotation is actually driven by the accelerometers, and it's moving it out. And then what it actually does for the Oculus is it creates a distortion map. So basically that's what's stretching it out. One of the really cool things you can see, you can't really see, you can see on my screen, but you can't really see it here, is that these lines, there it is. So one of the things it does is it actually does like the lenses have chromatic aberration that it splits the red, green, blue like a prism, and so the distortion map actually corrects for that. And you can see it on the screen. It's actually
So essentially, because those lights bend in a different, they actually correct for that in the when they split the camera.
Yeah, so it's pretty cool. It's like, it has to be designed because you can kind of see it a little bit there. It has to be designed specifically for the Oculus in that sense.
So one thing, last thing about VR, and we'll definitely do the AR stuff, is that this works on your phone. Like this polyfill will work in JavaScript on a phone in a browser. You can write JavaScript. Most of us have probably written at least one line of JavaScript in our lives. And you can get this working, and then you can throw it into a $15 Google Cardboard, which you can get off Amazon, and now you're playing with VR. So go on Amazon and get a Google Cardboard.
Yeah, and all you need to know is 3JS. Basically, if you already have existing 3JS code, like maybe a demo you've done, you can just plug this in. Mostly done.
This is a different one that you made.
Yeah, and I don't know if you want to talk about it, but so that's WebVR, which is really cool. But if any of you have ever played with Unity, Unity basically just have to plug in the Oculus. There's an Oculus plugin, and then immediately your 3D game is virtual reality, which is pretty cool.
Yeah, so we played this Unity as well for an AR project, and I think we had something running in a day, like not a long day. So I have that demo myself. You know,
Kyle Gordy's JavaScript. Always Kyle Gordy.
It's an augmented reality app that we did for Mitsubishi.
It is worth noting that like all the VR stuff that's going into browsers is still in spec, and so like are not spec rather, and so it is changing. And the guys who write the polyfills like keep up with it pretty quickly, but it does lag a little bit.
So the special code is on this Google employee's personal Google Drive.
Yeah.
It's kind of sketch.
But the Moss VR people, they have a really great IRC channel and they're super nice.
And they just recently got WebVR support on Android. So
Kick it.
yeah.
All right, augmented reality. This is looking through an iPad. This works on iPhone and Android as well. This is for Mitsubishi. They wanted us to basically do a repair manual, like how we talked about, you know, a tank or something. Got this, and a company called Matayo Volkswagen have done this on a car. But what we did is we created a 3D map of this air conditioning unit, and we're highlighting the different parts that you want to change for this specific repair. We actually had loaded up a few different 3D models, so you'll see as we take off the fan, it switches over and recognizes a different 3D model and goes to the next step from there. And it's got these really awesome corny animations of like lift it off, and there's one where like a screwdriver comes flying in out of nowhere to show you that that's what you need to do. It's super fantastic. Yeah, another one, I've been doing a lot of work with the Smithsonian museums. Let's see if I can find this. Smithsonians are fantastic. These guys are really interested in cutting edge technology. They unfortunately don't have the money to back that up most of the time. This is an app that we worked on and got about 90% of the way there before we went out of business. So what this is doing is, it's a thing. This is getting 3D maps off of skeletons. So we've scanned the skeletons and got those point clouds. And then we're registering off of those and triggering animations, putting up realistic 3D models.
So you're using the SLAM algorithm for all those. You basically like that for that machine, whatever it was, you like did. You got the point cloud from the machine itself.
What was so we talked a little bit about barrier to entry for VR, and we're kind of saying, you know, if you want to do it with your existing tools, you can. What's the story for AR right now?
AR is actually pretty easy to there's not very good open source stuff right now. There's one out of Georgia Tech that basically lets you put things, put up billboards in 3D space. If you want to do anything else, I always use the Matayo SDK. They've got the SLAM algorithm. They do, so you do 2D tracking, 3D tracking, geospatial. It plugs into Unity. It works on iOS and Android, and your full like pro license is maybe $3,500 to $5,000, but you can start developing and put in 5 lines of code. The project setup is a little more complicated, but put in 5 lines of code, and you've got an AR app that has a Matayo splash screen, and then once it's all done, you just pay, splash screen goes away, and you're good to go. So you can get started in it's about an hour.
Have you used Euphoria?
I've touched on it a little bit, but we always use the
So you don't, you can't really compare them.
I can talk about the different features, but not the use experience.
So definitely the size should be better. Something
I
like
think that they're the best. They consistently win. There's this, Georgia Tech has a competition for tracking algorithms where they basically set up like, it's like a digital obstacle course. So they'll do something really cool, like take a table and just put a bunch of like glasses and other like really shitty objects on there. And then you have to make a 3D map and track off of it. And they consistently win that competition. So.
Well, we're just about out of time. Definitely, we'll keep this up now. If you want to see, I have an AR demo on my phone right now. If you want to come up and see it, we did it with the not material, we did it with a different library program for you. We'll post all the links, everything we've talked about, all the technical stuff, so like all these libraries we're talking about. I'll post all of that to the meetup page. So if you're not on our meetup page, you should be on our meetup page. And we'll get that link out there. We'll keep this stuff out, so feel free to come up and play with this stuff. And other than that, let's give a big hand to our sponsor, or our panelist rather, for agreeing to this literally today.
If you're wondering how AR might touch your life like right now, I was actually in the Earlier Stroke Center on Saturday getting a tour, and they literally, one of their kind of cutting edge procedures they do, all the medical, the surgical tools are tagged with tracking targets, and the distance from the target up into the brain basically is all known about the tool. The tools are very tight tolerance, and when they do this procedure, a person in Israel from the company that invented the procedure sees all the medical imaging in real time, knows the exact pathway of the tool, and is basically giving the doctor feedback during the entire procedure using AR, which is really freaking cool. So, like, there are applications for it. It's a little bit like, for their application, they have to have targets and that sort of thing to have accuracy, so it doesn't fit into your everyday life as well as you'd like, but it is really cool.
You have other announcements to make before everybody, turn everybody loose?
I don't think, not right now.
No? All right.
So you can come play with the Oculus Rifts at the library on the 4th floor in Gig Lab. During 4 hours, we have 2 of them. So if you want to come experiment, write some WebVR code or Uni code, come there for 4 hours. So Tuesday through Thursday at 2 to 8, and
Friday and Saturday, 12 to 6.
Yes.
Last meeting announcement real quick.
Shaw Web starts May 19th of this month.
What does?
So Shaw, it's a meetup for Shaw for DevOps. We call it Shaw DevOps because it's part of the Shaw Dev stuff. So May 19th, public's going to be in, do a pretty cool demo. It's a meetup, so just go to meetup, look for Shaw DevOps.
Awesome. And with that, I think we'll call it a day. I'll see you all next week.